Hello everybody, this is the Physics Midterm Exam Review Worksheet for Grade 8 at the International School of Innovation. Let's start with some notes you have to study. You have to know about velocity. In order to describe a motion, we need both a reference of space and we need a reference of time, meaning that we need distance and we need time. We need d or l and we need delta t. A reference of time consists mainly of a clock, an origin of time, and a unit of time. What is a chronometer? What is the chronometer? The chronometer is an instrument which allows the measurement of time. So chronometer, instrument that allows the measure of time. What is the duration? Is the interval of time between two instants, between t1 and t2. This is called a duration. In the international system SI, the SI unit of time is the second of symbol small s. A moving object traveling a distance L, or maybe you're going to see this D, for example, distance. So during a time delta t has an average velocity. So you have to study this property. V average is equal to L over delta t. Distance over time. What is the instantaneous velocity? The instantaneous velocity is the velocity given at a specific instant. We have three types of motion. Either it can be uniform, where the speed of velocity is constant. We have accelerated motion, the speed or the velocity is increasing, or decelerated, where it is decreasing. For a uniform, as I said, the velocity does not vary with time, meaning that it is constant. While regarding accelerated motion, the velocity increases with time. That way increases, meaning that accelerated motion. For decelerated motion, the velocity decreases with time. So whenever it increases, it's called accelerated. Whenever it decreases, it's called decelerated. So you have to know these. These two somehow confusing. Accelerated, meaning the velocity increases. Decelerated, meaning that the velocity decreases. Whenever the velocity stays constant, it does not vary with time, this is called a uniform. So we have three types of motion. We have either uniform, accelerated, or decelerated. Now we're going to move to forces. What are forces? What is a force? A force represents a mechanical action. What is a force? The force is something that can create, prevent, or even modify a motion of a body. It's also the cause for the deformation of a body. Moving now to dynamometer. Dynamometer, what's the function of the dynamometer? It's an instrument used to measure the magnitude of a force. So dynamometer, instrument that measures the magnitude of a force. What is the unit of force? The unit of force is Newton of symbol capital N. So Newton is the unit of force of symbol capital N. The force should be represented by a vector, for example, force F. Here is the force F. You have to represent it by a vector. This is force F. Having a point of application. For example, this point O, this is the point of application. Direction, whether it's vertical or horizontal. A sense, either right, left, upward, downward. And the magnitude, for example, let's say the magnitude of this is 5 Newton. You have to take into consideration the scale. You have to follow the scale that's given in the question. For example, if I told you 1 centimeter represent 1 Newton. So 5 Newton, how many centimeters? Simple calculation, 1 centimeter is 1 Newton. So 5 Newton, it's 5 centimeter. The force of contact is a result of contact between two bodies. Whenever this contact stops, this force disappears. A force at a distance exists when two bodies are separated by a distance. So we have contact or acting from a distance. Contact, whenever they are in contact and this force stops when they are separated. Acting from a distance, this force exists when the forces or the two bodies they are separated at specific distance. Now we have some force that are somehow special. This is called the friction. A force of friction, what does it do? It disturbs the motion. It's sometimes useful. Listing the forces acting on a body signifies stating the direction and the sense. First of all, you have four characteristics of the force. You have one, point of application. You have number two, direction, line of action. Three, sense. And number four, which is the magnitude. Let's start together with question number 1. Consider the instrument represented in this figure. Give the name of this instrument. Simply, this is the speedometer. What does this instrument measure? It measures the instantaneous velocity of a moving object. So instantaneous as a specific instant. In which unit is this instrument graduated? As you see here, kilometer per hour. So you have to say kilometer per hour. Here if you say 20, this here 25. Here we have 30. This is 35, 40, 45. So each one is present 5. So here we have 100. This is 105 and this is what? 110 kilometer per hour. Moving to part 3. 3 in which unit? We say that kilometer per hour. Number 4, express the indicated value in the SI unit. So SI unit is the meter per second. It's 110 kilometer per hour. So we have 1 meter per second. It gives 3.6 kilometer per hour. If you want to say 110 kilometer per hour represent how much in meter per second? So this will be 110 divided by 3.6. So this will be 30.55556. Take 3 digits only. So 30.556 meter per second. Moving to part 5. Calculate the distance covered by this moving car during 4 hours. So the time is equal to 4 hours. This moving car, so the average velocity is going to be 110 kilometer per hour. So you have to calculate the distance. All of you know that V average is equal to D over delta T over T. Simply D cross multiplication, so D is equal to V times T equal to 110 kilometer per hour times 4 hours. So this equals 440 kilometer. Be careful here to have the same velocity and the time, the same unit. It's 4 hours should be in kilometer per hour. If it was in minute, in second, sorry, so this will be in meter per second. Okay, be careful for this. Question number 2. Represent the forces that have the following characteristics. Here we have a given scale that 1 centimeter, it represents a 2 Newton. So first one, F1, its point of application is at point A. This is point A, let's say. This is point A. It's horizontally to the left. To the left, you're going to move right here. Horizontal to the left, it should be straight. Okay. Horizontal to the left, this is F1. F1 equal to 10 Newton. So 1 centimeter gives 2 Newton. 10 Newton, how much? It's 10 times 1 divided by 2, it's 5 centimeters. So this should be 5 centimeter. And its direction toward the left, you have to put an arrow. And this is F1 factor. F2, at point B, vertically downward. Vertically downward, meaning that it should be vertical, downward. This is point B, for example, vertically downward, 5 Newton. So 1 centimeter gives 2 Newton. Here we have 5 Newton. it's equal to how much? It's 5 times 1 divided by 2. It's 5 divided by 2, so it should be 2.5 centimeter vertically downward. This is vertically downward, 2.5 centimeter downward, and this is F2. F3 is 40. At point O, this is point O, inclined. This is the horizontal, let's say. Inclined by 60 degrees with the horizontal upward to the right is 60 degrees. You put the protractor. F3 equals 60 newtons, so this should be 3 centimeter. So upward to the right, you have to put the protractor here in this region. You had count 10, 20, 30, 40, 50, 60, and whenever you reach 60, you can draw this one. This is F3. This should be 3 centimeter, and this point is O. Going to point D, inclined by 30. This is point K, let's say. This is K. Inclined by 30 degrees with the horizontal. 30 degrees with the horizontal, downward to the left. This is the horizontal. Downward to the left, so it should move to this direction. This is the left. Okay, downward to the left, such that F4 equal to 80 newtons, so it should be 4. You have to put a protractor here and measure 30 degrees, and this is 30 degrees. This is F4, say that it is 60, and here this is 30 degrees Celsius. This is F4 with a value of 4 centimeter. Question number 3. Let's start with the question number 3. In the bicycle race, the average speed of the bicycle was 8 meters per second, where the total covered distance was 0.576 kilometers. Calculate the average speed of the bicycle in kilometer per hour. So you have to convert 8 meters per second to kilometer per hour. As we said, 1 meter per second, it gives 3.6 kilometers per hour. Okay? Here, 1 meter per second. If you have 8 meters per second, it gives how much in kilometer per hour? So it's 8 times 3.6. So it's equal to 28.8 kilometer per hour. Calculate duration of the whole race. All of you know that V is equal to D over T. I want to calculate the duration. This goes up and this goes down. So T, going to calculate this here. So T, it's equal to D over V. It's equal. I have the distance here. Distance is 0.576 kilometer, 0.576 kilometer over velocity, which is 28.8 kilometer per hour. So this is going to be 0.02 hours. Even though you can calculate it in another way, you can calculate it in meter per second if you want, and the time is going to be in second, the same way. Moving to part 3. Calculate the distance covered by the bicycle during 10 minutes when traveling at 8 meters per second. So the V is equal to 8 meters per second. And here we have time, it's equal to 10 minutes. 10 minutes to be converted into seconds, it's times 60. 10 times 60, so it's equal to 600 seconds. So V equal T over T. V is equal to, so we have the general formula is V equal to D over T. So we have to calculate what? We have to calculate D. It's equal to V times T. It's equal to 8 times 600. So it's equal to 4,800 watt meter. Part 4. At a certain time, the bicycle covered a distance of 0.4 kilometer during 8 seconds. So distance is equal to 0.4 kilometer. Time is equal to 8 seconds. Find the average speed. So V average is equal to D over delta T. We have D, we have delta T, but we have to convert 8 seconds into time. So for example, or either we have to convert T equal 8 seconds, we have to convert it into another time. So first step, 0.4 We can multiply it, for example, by 1000, so it will be 4000 meter. Then V average, then V average is equal to D over T, so it's equal to 4000 meter over T, which is 8 seconds, so it's equal to 50 meter per second. You have to be careful for these units, okay? You have to be meter seconds, or either kilometer. This B should be converted into hour. Name the device used to measure the instantaneous velocity speed of the bicycle. This is called the speedometer. Okay? This is okay, so make sure to have the same units: meter, second, so it's meter per second, kilometer per hour. Okay, so let's continue please to question number 3 here. As I said, be careful for the units, be careful how to start calculation, be careful to put the same units. For example, we have distance in meter and the time in second. Here we have meter per second. Either we have distance in kilometer, time in hour, so we have kilometer per hour. Okay, this is the composition of each of these calculations. You have to be careful for this, otherwise your calculation is going to be wrong. Okay, be careful. Meter, seconds, we have hour, minute, we have second, so hour to minute is times 60, minute to second is times 60, from hour to seconds 3600, and vice versa here. A bullet is ejected from a pistol of an average speed 800 meter per second. So the V average is 800 meter per second. This is how you have to think in the exam. I am going to read to understand the given one, and then I have to start solving. Calculate the distance covered by the bullet during 1.5 seconds. How I have to calculate this? First of all, V average is equal to distance over time. So we have what? We have to calculate D. So distance, or D, sorry, this is D, it's equal to V times T. This is in second, this is meter per second, this is okay. So we have to calculate 800 times 1.5, so it's equal to 1200 meter per meter, this is distance, so 1200 meter. Calculate the time elapsed between ejecting the bullet, hitting a wall 500 meter, this is D, away from the pistol. Okay, average speed, we have it here, you have to use it. So V average equal to D over T. I have to calculate time, so T comes here, V average down there. So T is D over V average. It's equal to 500 over 800. So it's going to be 0.625 watt seconds. Okay, be careful here. 800 meter per second is the average velocity. 1.5 seconds is the time. For example, if I have it in kilometer per hour, for example, if it's kilometer per hour, what I have to do? Either I have to change kilometer per hour into meter per second, or I have to change 1.5 second into hour. This is two choices. You choose the one. I want only one way in the exam. Okay, for example, in the exam I may give you a table to draw, a table showing the distance and the speed, for example, and they say you have to convert the table into a graph. You know how to convert the table into the graph, and you have to calculate graphically and somehow, so be careful about this. Okay, question number 5. Classify the following forces as a tension of the string, contact forces or forces acting from a distance. Starting with the tension of the string, this is a contact force. Weight of the body acting from a distance. Reaction of the support, this is a contact force. Magnetic, it's acting from a distance. And finally we have friction, which is a contact force. Be careful for these. Maybe I'm going to give you these in a question. You have to know how to calculate this. Okay? Good luck guys. Study well. Bye bye. Here we move to the lesson of weight. What is weight? Weight is force of attraction exerted by the earth on this body. As we know, the weight is expressed in its SI unit, which is the Newton of the symbol and capital. While the difference between the weight and the mass of the body is the amount of matter it contains. Also, we have a difference, which is the main difference. The weight is variable according to the place, while the mass is always constant. It doesn't change. The SI unit of the gravity, G, it's Newton per kilogram, where the formula of the weight, W, it's equal to M, which is the mass, times G, which is the gravity. The unit of gravity is always Newton per kilogram, and also the weight, it should be in Newton, and the mass, mainly it should be in kilogram. Okay, so let's start with the first exercise. Question number 1. A car leaves Beirut at 7:15 a.m. and arrives Saida at 8:05 a.m. So the distance is 50 kilometers. So 7:15 a.m. and 8:05 a.m. What is the duration here? 7:15 to 8:05, it represents about 50 minutes. Okay, this 50 minutes. And the distance here is 50 kilometers. 7:15 to 8, it's 45. 8:05, it's 50. What does the numbers 7:15 and 8:05 represent? 7:15 and 8:05, they represent instants of time. Part B. Calculate the average velocity in kilometer per hour and in meter per second. First, before I want to start any question like this one about velocity, you have to determine the time and you have to determine the distance. First, I have to calculate in kilometer per hour. 50 minutes to be converted into hour, it's divided by 60. So it should be 0.833 hours. Okay, 0.833 hour. So in order to calculate V average, you have to know this property. It's equal to L over delta T, or equal to D over delta T. So it's equal to the distance, which is 50 kilometer, divided by the time, which is 0.833 hour. So the velocity should be in kilometer per hour, since we have kilometer here and we have hour here, so it's gonna be 60.024. We have to calculate it in meter per second. As we know, 1 meter per second go for 3.6 kilometer per hour, so V average is equal to 16.673 meter per second. Part C. Another car covered the same distance. This is a big hint here. The same distance, which is 50 kilometers, with a velocity of 25 meter per second. So V is equal to 25 meter per second. As we know, V average is equal to distance over time. I want to calculate time, so time is equal to D over V average. So equal, I want to calculate D, it's kilometer, 50 kilometer, while velocity is 25 meter. So I have to convert one of them to the other unit, either kilometer to meter or meter per second to kilometer per hour. I prefer 50 kilometer to be in meter, so it's 50,000 over 25, this is meter, over 25 meter per second. So the time should be in seconds, gonna be 2000 seconds. To be converted in minute, divide by 60, so it'd be 33.333 minute. A third car moves a velocity 25 meter per second. The time here is 35 minutes. 35 minutes to be converted in a second times 60. So 35 times 60. Okay, so 35 times 60 is gonna be 2100. So V equal to D over T. I want to calculate distance, so cross multiplication, D it's equal to V times T. It's equal to V, it's 20 meter per second times T, it's 2100 seconds, so it will be 42,000 meter. If I want to convert it into kilometer, it's gonna be 42 kilometer. So pay attention to the units. You have to use the same units, you have to use the same formulas, and so in this way you're gonna solve a question with a full mark. You have to use the unit first, the first formula, which is V equal D over T. This is the most important here, and you have to know how to convert from meter per second to kilometer per hour, from minute to hour to second, and so on. Here we move to question number 2. Question number 2 says you have a iron ball and a magnet. List the forces acting in the ball. Show them. First, we have the weight of the ball. This is W. We have the tension along the string. This is T. And we have the force of attraction. It's called by the magnetic force mg. So we have weight of the ball, weight of the ball, we have tension along the string, and we have the magnetic force According to their type, you have to classify them according to their type. All of you know we have two types, either contact or acting from a distance. Contact forces is the tension along the string is a contact, while acting from a distance is the weight and magnetic force. Okay, write the characteristics of the two of these forces. I want to choose two. We have three, choose two. I'm going to choose weight. We have point of application. We have direction. We have sense. And here we have magnitude. First, point of application. Always, whenever we have acting from a distance, the point of application is the center of gravity. Okay, so point of application is the center of gravity of the ball. We have direction, it's vertical or horizontal, it's vertical. Sense, it's downward. And magnitude, W equal to m times g here, it's unknown, we don't have the value. While moving to the magnetic force. Magnetic force, point of application, also it's the center of gravity. We have the direction. The direction is horizontal toward magnet, it's horizontal. And we have sense, it's to the right toward the magnet, and magnitude, it's here, it's unknown, we don't have the value of the magnetic force. So in every question you have to know the forces that are acting here, that are playing an important role here. You have to know first the forces, you have to know how to draw them. For example, here show them on the diagram without a scale. For example, in the exam I've told you 1 centimeter represent to 1 newton. If you have a force of 5 newton, how should it be? This is x, so it'd be 5 centimeter, for example. Okay, you have to know this. You have to know to classify them according to contact, and you have to classify them if they are acting from a distance. You have to know the characteristics of the forces. We have point of application, we have direction, we have sense, and we have magnitude. Okay, moving to question number 3. Question number 3 is talking about velocity also, but this is somehow tricky one. Let's see. A car leaves Tyre at 8:15 a.m. and reaches Saida at 9 o'clock, passing a distance of 45 kilometers. So this distance, 45 kilometers, this is an important hint here. Then it rests for 25 minutes. Then it rests 25 minutes at Saida. Since it rests for 25 minutes at Saida, so you have to calculate this. The car leaves Saida towards Damour. The time of the journey Saida Damour is 15 minutes, covering a distance of 18 kilometers. What is the starting time here? When did we start? At 8:15. So we start at 8:15. What is the total duration in minute and in second? Total duration. First, we have 8:15 to 8 to 9 o'clock. This is a 45 minute. So first, you have to calculate 45 plus resting for 25 minutes. You have to calculate it. 25 plus the car leaves Saida toward Damour. The journey between Saida and Damour is 15. So plus 15. So 35 plus 25, it's 70, 80, 85. So 85 minutes. We calculated in minute. You have to calculate it in second times 60. So it's going to be 5,100 seconds. At what time the car reaches Damour? At what time? You have to 45 minutes to reach Saida, 25 minutes resting, so we have about 85 minutes. Okay, so it reached Saida at 9, we have 25 or 15, we have 30, 40 minutes, so 9:40, so it reached at 9:40. What is the average velocity between tire Saida in kilometer per hour and in meter per second? We have to know that V equal D over T. So it's equal to distance, it's 45 kilometer over time, should be an hour, should be kilometer per hour. 45 minutes, it's 0.75 hour, so it is 60 kilometer per hour. Small calculation, 1 meter per second, 3.6 kilometer per hour, so it should be 16.66666. So you have to take the last number, which is 7, so 667 meter per second. Only 3 digits, it's okay. You can take only 3 digits, this is okay. What is the velocity between Saida Damour in meter per second? This is part E. So part E, what is the velocity between Saida Damour in meter per second? We have V, it's equal to distance over time. Saida Damour, the distance is 18 kilometer. I want to calculate it in meter per second. So 18 kilometer should be converted to meter, so it's 18,000 meter over the time, which is 15 minutes. Minute to be converted to second, it's 900 seconds. So 0 by 0, 0 by 0, 180 divided by 9, it's 20 meter per second. Part F, what is the average velocity between tire Damour in kilometer per hour and meter per second? First, we have to calculate the distance. It's 63 kilometer. How? 45 plus 18, 45 plus 10 is 55, 55 plus 8 is 63 kilometer, so D equals 63 kilometer, so it's equal to 63,000 meter. This is the first step. V, it's equal to D over T, it's equal to 63 kilometer divided by 63 kilometer if divided by time, it takes about 85 minutes, which is a 1.4167 hour, so it's going to be 44.469 kilometer per hour. To be converted into meter per second, this is going to be 12.3525 meter per second. Okay, this is an important question. This 25 minute here, this is a tricky one. You have to pay attention to this, and you have to know how to take the definite time, how to convert. Whenever you are using kilometer per hour, the time should be in hour, the distance should be in kilometer. When you are using the time, the distance or the velocity in meter per second, you have to choose the time in seconds and the distance in meter. Moving to the last question. Last question is an easy one. We have a table that represents the weight of an object M, of mass M, with respect to many planets and the gravity on these planets. Here we have the Earth. This is the key here. We have to calculate the mass. All of you know that W equal M times G. So W equal M times G. So M, it's equal to W over G. it's equal to 49 divided by 9.8, so it's going to be 5 kilograms. So the mass here is 5 kilograms. By this formula, you can calculate this. The same, W equal m times g. Here we have weight and we have mass. You can calculate gravity. It's going to be 3.52. Here it's 43.5. Here it's 18.64, and here it's 26. This is an easy question. Only you can apply this formula. You have to know it. W equal m times g. Be careful how to use the formulas. Be careful to study the properties of the forces, to study how to convert from meter per second to kilometer per hour and the opposite, how to convert between hour, minute, second, how to convert between meter to kilometer, how to use the different units. You have to make sure that G is in SI unit, Newton per kilogram, mass should be in kilogram. So this is an important way to solve these questions. Be careful, study well, good luck.